Okay. Hi, everyone. This is going to be a walkthrough of question 3 on exam prep week 4 on inheritance. As a preface, this question is very difficult, so no worries if you guys were confused or didn't have any intuition on where to approach it, on how to approach it, okay? So what we're trying to do in this question is assign y and z a static type and a dynamic type such that these criteria are true, okay? And looking at this criteria, we'll see that y dot fish z should equal z dot fish z, z dot fish y should equal y dot fish y, and then z dot fish z should not equal y dot fish y. Okay? So how are we going to approach this? My idea is let's just look at the possibilities for how we can define the static type of y and the dynamic type of y, and how we can define the static type of z and the dynamic type of z, and see if we can quickly start eliminating them, okay? So looking at the static types, okay, we can either go A, okay, and this is defining static type A to y, static type A to z, right? Or we can go, let's just put, there's 4 possibilities here, right? We can go AA, AB, BA, or BB, okay? So looking at these, it seems like, oh my gosh, there's so much to consider, but we can actually eliminate half of these from the start, okay? So I'm going to argue that these two are the same possibility, okay? The reason for this is the nature of how these equality statements are made. It doesn't matter which one is y and which one is z, because we can easily swap them, and the statements of equality should still be true, okay? So prove to yourself that if you swap y and z here, the exact same statements exist. Okay? So what that's saying is that these two are indeed the same possibility, so we can ignore one of them. Okay? And then looking at the last possibility, we see that if the static type of b is y, the static type of z is also, if the static type of y is b, and the static type of z is also b, that entails the dynamic types are both b, because you can't have a static type of a, and this is saying that y is equal to z, but if y is equal to z, then this can never be true, right? If y is equal to z, right? That's a bad way of doing object comparison, but for the sake of this example, if y is equal to z, then z dot fish z will equal y dot fish y, right? But that shows that invalidates point 3, so we can eliminate this possibility, okay? And we can take a step further to eliminate any possibility when y is equal to z, right? So looking at this top example, there were 3 possibilities for the dynamic of the dynamic type of y and the dynamic type of b, right? We can either have a, right, that's one possibility, a, b, actually there's many possibilities, ba, or what's the last one, bb, okay? These are all of the possibilities for the dynamic types of y and z if they're defined as above. Defined in this case. But we can eliminate so many of these very quickly. We can eliminate this possibility because y and z can't be equal. We can also eliminate this possibility for that same reason. And then we can eliminate this possibility because it's the same as this one, okay? So indeed, we're only left with one possible way of making static type A and dynamic type A for y and z. And that is if one of them has a dynamic type A and one of them has a dynamic type B, okay? So let's say that this is the possibility where we're considering if y has static type A, dynamic type A, if z has static type A, dynamic type B, okay? Except this possibility is not going to work. The reason it's not going to work is because it'll always call this function, right? if you guys try to prove this to yourself, reason that whenever we call any function fish, it'll have to take in an instance either a or z. Both a and z, both y and z, okay, there's a lot of names here, okay? Both y and z have static type a, so if we call the fish function that takes in an instance of static type a, it can only ever call this function, which entails this last condition will never be true. Okay, so we've eliminated this possibility. This is the only valid pairing, only valid assignment of static types and dynamic types that is left, okay? And in this assignment, you'll see there's two possibilities for dynamic assignments. We can either have A, B, or we can have a possibility of BB, okay? So let's first consider this case where Y has static type A, dynamic type A, B has static type, or Z has static type B and dynamic type B, okay? So in this possibility, this won't work because we can simply look at this first condition right here, okay? Looking at this condition, y.fishz will call, let's look at which method, it'll call this method right here, right? Because y is an instance of static type A, so it'll look in the A class for a function that takes an instance of type B, and it'll call that instance. But when we do z.fishz, it'll call this function right here, okay? So we can eliminate this possibility, and then we only have one possibility left. So looking at this possibility right here, we're going to quickly walk through some steps to ensure that it works, even though that we know it has to work by process of elimination. Okay, so looking at this last case, we're going to quickly walk through all of these assignment statements. Okay. Okay, continuing, I had a quick Slack notification. So looking at this assignment, we want to prove to ourselves that these three statements, 1, 2, and 3, are true. Okay. Looking at the first one, y.fishz will go in class A, right? Because that's what y's static type is. And it'll look for a function, fish, that takes in an instance of type B. It finds it, then using dynamic method selection during runtime, it'll choose this function right here, okay? So this first check is true. The second check, z.fishy is equal to y.fishy, what that one will do is look in class B, because that's z's static type, for a function that takes an instance of type, right here, type B, okay? And it finds one, right, the same method, okay? So the first check is true. Then we can look at the second check, z.fishy is equal to y.fishy. What that one is doing is it looks for a function in class B that takes an instance of static type A. It doesn't find it. Using an inheritance, it selects this function. Then when you do y.fishy, it'll also choose this function, okay? So they both choose this function, and then the second check is also true. And then the last one has to be true, because since 1 and 2 chose different functions, and z.fishy is here, y.fishy is here, we know that they aren't equal, okay? So the final solution is if we say that y's static type is A, dynamic type B, z's static type is B, dynamic type B, and as we mentioned in the beginning, we can also swap the ordering here. So this is also valid by that symmetry argument, okay? So that's all. This one was a very tough problem, so no worries if it didn't make too much sense. But yeah, have a good time studying for the midterm.